Polydecamethylene adipate, density 0.99 grams per centimeter cube, was mixed with various quantities of dimethylformamide of density 0.9445 grams per centimeter cube, and the melting temperatures observed for volume fractions of DMF 0.078, 0.202, 0.422, and 0.603 are 72.5, 66.5, 61.5, and 57.5 centigrade respectively. What is the melting temperature of the pure polymer? What is the heat of fusion of polydecamethylene adipate? To solve this, we want to first start off by writing the equation 1 over Tf equals negative R over delta HF times Vu over V1 times little v1 plus 1 over Tf0, where Tf0 is the melting point of the pure polymer, Tf is the melting point of the polymer solution, delta HF is the heat of fusion, Vu and V1 are the molar volumes of the polymer and the solvent, and little v1 is the volume fraction of the solvent. This equation is of the form y equals mx plus b, where if we plot a graph of 1 over Tf versus little v1, which is the volume fraction of the solvent, negative R over delta HF times Vu over V1 will be the slope, and 1 over Tf0, the melting point of the pure polymer, would be the y-intercept. The slope should be equal to negative R over HF times Vu over V1, and the y-intercept would be 1 over Tf, which is the melting point of the pure polymer. The points that we have are V1 and Tf in centigrade, 0.078 at 72.5, 0.202, 66.5, 0.422, 61.5, and 0.603, 57.5. So we have to first convert this to Kelvin, and that gives us 345.5. For 66.5 plus 273 is 339.5. 61.5 plus 273, 334.5, and this is 330.5. And 1 over Tf is going to be, for 345.5, it's 0.00289. So we would rather make this as 1 over Tf times 10 cube, so that we can write it as 2.894, 2.946, 3.000, and 3.026. So now that we have the values of 1 over Tf and V1, we can plot the graph. So since the values for V1 go from 0.078 to 0.603, I'm taking it from 0.0 to 0.6, and 1 over TF times 10 cube, the values go from 2.894 to 3.026. I'll start from 2.0 here, 2.5, 3.0, 3.5. Now we are ready to plot this. The first point is 0.078 and 2.894. So the second point is 2.202 and 2.946. 0.422 and 3.000. 0.603 and 3.026. Something like this. So I'm getting the y-intercept at 2.89 times 10 to the negative 3. And my slope calculation is, I want to choose 2 points. I'm choosing a point P1, which is 0.5 and 3.0 times 10 to the negative 3, and I'm choosing a point P2, which is the y-intercept itself, so it is 0.0 and 2.89 times 10 to the negative 3, and so my slope is 0.22 times 10 to the negative 3. Negative R over heat of fusion times the molar volume over V1. We can now try to find out what Vu and V1 are. Now we have to find out the molar volume of the polymer. So for the molar volume of the polymer, let's first find out the molar mass of the polymer and divide that by its density. So to find the molar mass, let's write down the structure. The polymer is given to us as polydecamethylene adipate. Decamethylene is CH2 10 times, and then adipic acid is CH2 4 times COOH. So that would be OCO, CH2 4 times COO, and so on. So this is the polymer structure. Let's find out the molar mass of this. We have 14 methylene groups. Each methylene group is CH2, which is 14, so 14 times 14. And then there are 2 carbons, which is 2 times 12. There are 4 oxygens, so 4 times 16. It comes to 284 grams per mole. So Vu is equal to 287 centimeter cube per mole. Next is V1. We have to find out the volume of the solvent, the molar volume of dimethylformamide. Dimethylformamide is 2 methyls on the nitrogen. So the molar mass of dimethylformamide would be, we have 2 methyls, each methyl is 15, so 2 methyls is 30, nitrogen is 14, carbon is 12, oxygen is 16, and 1 hydrogen, so that is 73 grams per mole. So V1 would be the molar mass which is 73 grams per mole, over the density, which is given to us as 0.9445 grams per centimeter cube, and that is 77.3 centimeter cube per mole. So delta HF is minus R over the slope times VU over V1, that is minus 8.314 joules per mole per Kelvin over the slope, which is 0.22 times 10 to the negative 3 per Kelvin times VU, 287 centimeter cube per mole over 77.3 centimeter cube per mole. This gives us a delta HF of negative 0.140 joules per mole. Now the y-intercept we got is 2.89 times 10 to the negative 3 per Kelvin, and that is equal to 1 over TF. So TF is 1 over 2.89 times 10 to the negative 3, which is 346 Kelvin, or 346 minus 273, which is 73 degrees centigrade. So we have delta HF and melting point of the pure polymer.